Example number 9, we're going to write the following polynomial as a product of linear factors and list all zeros of the function. So here, since they don't give us a 0, we would do the rational test. So here we have our 8. Our 8 will be an, our x to the 5th will be our 8. I'm sorry, our 8 will be a sub 0, a sub o, or and then our x to the 5th, a sub n. So again, remember that's an over a, I'm sorry, a o over an, and then p over q. So we write the factors of 8. So that's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. The good thing is that for our leading coefficient is 1, so the factors for that is just plus or minus 1. So our possible zeros are plus or minus 1, 2, 4, and 8. Remember that we're getting these numbers because we're saying 1 divided by 1 is 1, plus or minus, 2 divided by 1, plus or minus 2, and so on. Okay. And we check our signs for positive. Here, I'm just going to write it down here again. So here's positive, 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 and then negative, so there's a sign change, and negative, positive, so it's another sign change. So we have 2 or 0 positive zeros. Now if we check our negative, so this should be negative x. And then plus 8. So here we have negative to the 5th, so that's a negative x to the 5th. And then we have a negative, positive, negative, so a negative x cubed. At negative x squared, that's positive, so 2x squared. And then you have a negative and negative, you have negative plus 12x, and then plus 8. So we have a negative, negative, positive, so that's a change, positive, positive, so just 1, negative, 0. So let's go ahead and test some of these numbers. So we're just going to try f of 1. So that's 1 to the 5th, 1 cubed, plus 2 times 1 squared minus 12, 1 plus 8. So that's 1, 1, that's 2, plus 2, 4, plus 8, 12, minus 12, so we get 0. So our x is equal to 1, and our factor is x minus 1. So let's use synthetic division. So I'm going to list the exponents. So x to the 4th, x to the 5th, x to the 4th, 3rd, 2nd, to the 1, and then your number. So x to the 5th is 1, x cubed. Well, what follows is x to the 4th. It's missing, so it's 0. X cubed, 1. X squared, 2. X, negative 12, and then we have 8. So here we're going to lower the exponent, so x to the 4th, x cubed plus 2x squared plus 4x minus 8. So that's our reduced polynomial. Let's try some more numbers. So substituting a negative 1 into this polynomial right there. We end up with 20. So we'll move on to 2. Again, we'll substitute it into this polynomial. we end up with 32. Substitute -2 into this polynomial, and we get a 0. So our x is equal to -2, so our factor is x plus 2. So now we have two factors. We have the x minus 1, and then we have x plus 2. Let's go ahead and use synthetic division, so -2. And I'm looking at this polynomial, so we have x to the 4th, x cubed, x squared, x, and negative, and then our number. So we have 1, 1, 2, 4, -8. All right, so let's lower the exponent. So x cubed minus x squared plus 4x minus 4. So this is our reduced polynomial. So we could continue doing this, checking numbers, but right here, these two have something in common and these two have something in common. So we could factor by grouping. So that means we could group x cubed minus x squared plus 4x minus 4. So we could factor out our x squared. So here we have x minus 1, and then we have plus. We could factor out a 4 here, so 4x minus 4. I mean x minus 1. So here we have x squared plus 4. And our second factor is x minus 1. So x squared plus 4 is equal to 0. So x squared is equal to -4. Take the square root. So we end up with plus or minus 2i. So we have imaginary. And then we have our next factor, x minus 1. So that's equal to 0. So x is equal to 1. So our linear factors of this, let's go ahead and write it. Will be our first, will be this one right here, x minus 1. Followed by x plus 2. Followed by this one right here, so x minus 1. Followed by our imaginary, so we have our complex, x plus 2i and x minus 2i. So what you notice here that these two repeat, so we could say f of x is equal to x minus 1 squared, followed by x plus 2, x plus 2i, and x minus 2i. So this is our linear factors. Now for our zeros, we have x is equal to, our first one was 1, so x is equal to 1. Our second one was x is equal to -2. And then notice that we have it repeats, right? We have x is equal to 1, so x minus 1 repeats. Repeats twice. So you could write it again, or you just say it repeats. And then the other ones is x is equal to plus or minus 2i. So those are our zeros. So this will be our whole complete answer.